Welcome to Algebra 1, Unit 7, Lesson 24 Practice Problems. This lesson will review everything we've gone over in Unit 7 and give us good practice before the final test. For number 1, the function h represents the height of an object t seconds after it is launched into the air. The function is defined by the function h of t equals negative 5t squared plus 20t plus 18. Height is measured in meters. Answer each question without graphing. Explain or show your reasoning. Number 1, after how many seconds does the object reach a height of 33 meters? Well, if we're looking for a height of 33 meters, then we would set the equation equal to 33. So we're going to have negative 5t squared plus 20t plus 18 equals 33. Before we can use the quadratic formula, we need to set this equal to 0. So we're going to subtract 33 from both sides. This becomes negative 5t squared plus 20t minus 15, because 18 minus 33 is negative 15. And now it equals 0. Now that we have a standard form quadratic function equal to 0, we can identify a, b, and c. A equals negative 5, b equals 20, and c equals negative 15. We can substitute these into the quadratic formula, and we have t equals negative b, which is 20, plus or minus the square root of b, which is 20, squared, minus 4 times a, which is negative 5, times c, which is negative 15. And all of this is over 2 times a, which is negative 5. So we have negative 20 plus or minus the square root. 20 squared is 400, and negative 4 times negative 5 is 20, and 20 times negative 15 is negative 300. Two times negative 5 is negative 10. So now we have t equals negative 20 plus or minus the square root. 400 minus 300 is 100. And the square root of 100 is plus or minus 10. So now, if we divide everything by negative 10, we're going to have 2 plus or minus 1 over 1. So our two options are that t equals 2 plus 1, which is 3, or t equals 2 minus 1, which is 1. So at 1 second, the object reaches a height of 33 meters, and at 3 seconds, the object reaches a height of 33 meters. Number 2, when does the object reach its maximum height? For number 2, we're going to take the two values we just found, we're going to add them together and divide by 2. This is 4 divided by 2, which is 2. So it reaches the maximum height at t equals 2 seconds, because the vertex will be exactly halfway between these 2 points because of its symmetry. And number 3, what is the maximum height the object reaches? Well, now we know the time that it reaches the maximum height, so we're going to substitute this in, and we have h of 2 equals negative 5 times 2 squared plus 20 times 2 plus 18. 2 squared is 4. Negative 5 times 4 is negative 20. 2 times 20 is 40. And finally, negative 20 plus 40 is positive 20. Plus 18 is 38. So that is 38 meters is the maximum height. If you have any questions about how to solve a quadratic function like this, please ask for clarification now so that you will be prepared going into the final test on Thursday. Practice problem number 2. The graphs that represent a linear function in blue and a quadratic function in black are shown here. The quadratic function is defined by 2x squared minus 5x. Find the coordinates of r without using graphing technology and show your reasoning. So the first thing we need to do is find an equation for the linear function, because they've already given us an expression for the quadratic function. So what I can do is find the slope. And if you remember, the slope is the change in y. It went from 5 down to 0, so that's negative 5, over the change in x. It went from 0 to 2.5. So negative 5 divided by 2.5 is negative 2. So now we could do the slope-intercept form. Which is y equals mx plus b, where b is the y-intercept and m is the slope. So this would be a slope of 5 and a slope of negative 2 and a y-intercept of 5. So now I have an expression for the linear term and I have an expression for the quadratic graph. So now I can set those equal to each other to find out where they cross. So I could say 2x squared minus 5x equals negative 2x plus 5. I'm going to add 2x to both sides. So this becomes 2x squared minus 3x equals 5. And then I'm going to subtract 5 from both sides. So that becomes 2x squared minus 3x minus 5 equals 0. Now I can identify A, B, and C. A equals 2, B equals negative 3, and C equals negative 5. Now we're going to put these into the quadratic formula. X equals negative B, which is negative 3, plus or minus the square root of B, which is negative 3, squared, minus 4 times A, which is 2, times C, which is negative 5. And all of that is over 2 times A, which is 2. So we've got 3 plus or minus the square root of 9 plus 40 over 4. That gives us 3 plus or minus the square root of 49 over 4. The square root of 49 is plus or minus 7. So we have two options. Either 3 plus 7 is 10, and 10 divided by 4 is 2.5, and that would be this intersection right here. Or 3 minus 7 equals negative 4, and negative 4 divided by 4 equals negative 1. That is going to be this point R. So we know it's negative 1. Now we need to know what the y value is. So we're going to take the quadratic expression and we're going to substitute negative 1 into it. So we have 2 times negative 1 squared minus 5 times negative 1. Negative 1 squared is 1. 2 times 1 is 2. Negative 5 times negative 1 is positive 5. And 2 plus 5 is 7. So R is at negative 1, 7. If you have any questions about how to solve a problem like this, where a linear graph and a quadratic graph cross each other, please ask for clarification now before we move on and get ready for the test on Thursday. On our last practice problem, Diego finds his neighbor's baseball in his yard about 10 feet away from a 5-foot fence. He wants to return the ball to his neighbors, so he tosses the ball in the direction of the fence. Function h, defined by h of x, equals negative 0.078 x squared plus 0.7x plus 5.5 gives the height of the ball as a function of the horizontal distance away from Diego. Does the ball clear the fence? Explain or show your reasoning. So, when it says as a function of the horizontal distance away from Diego, this is x. So if he is 10 feet away, then we can substitute 10 in for x. So we have h of 10 equals negative 0.078 times 10 squared plus 0.7 times 10 plus 5.5. 10 squared is 100. We have negative 0.078 times 100, which means we move the decimal 2 spots to the right, and we get negative 7.8. When we multiply 0.7 times 10, we move the decimal point 1 spot to the right, and that becomes 7 plus 5.5. Negative 7.8 plus 7 is negative 0.8. Negative 0.8 plus 5.5 is 4.7. So the height of the ball after 10 feet is only 4.7 feet. The fence is 5 feet tall. The ball will hit the fence. If you have any questions about how to apply what we've learned about quadratic functions to real-world examples like this, please ask for further clarification now so that you are prepared for the final test on Thursday.